Last time on Engineering the Jigsaw, we talked about what a large language model, or LLM, is. We described how an LLM works with language and predicts how text probably continues. We also described how LLMs don't understand meaning like a human being and cannot take responsibility. An obvious next question then is, if that's what an LLM is, how might we actually use one in practice? Real engineering work, after all, would rarely fit into a single prompt and a single answer. How can we go beyond those one-off interactions? Let's go find out. Hi everybody, I'm Ian Cunningham from VectorGB. Welcome to this foundation level episode of Engineering the Jigsaw, foundation episode number 27, How Might We Use a Large Language Model, or LLM for short. In F26, we described how a language model is a piece of software that has learned patterns from large volumes of text. And we highlighted that a useful summary of what they do is that language models, such as LLMs, predict how text probably continues. And they are large in the sense of their training data and their internal model parameters. So to repeat, the large in LLM refers solely to scale. It does not mean clever, and it does not mean correct, and it certainly doesn't mean reliable. In F26, we did, though, skip a lot of terminology that you might hear in an engineering environment, such as agents, agentic workflows, context, model context protocol, or MCP for short, and also retrieval-augmented generation, or RAG. Now, these all relate to how you might use an LLM beyond a single chat prompt. And we'll now dig into those in turn. So if we want to move beyond a single prompt, we may want to use an agent. An agent is not a new type of model. It is a piece of software that's typically implemented as a loop around an LLM. And instead of starting with a question, the agent starts with a goal or a task. The agent then repeatedly follows a simple pattern to think about the next step, to take an action, to observe the result, and then continue towards its goal. You might have heard of this being described as observe, plan, act, which is another way to refer to those steps that the agent takes. Agents, though, we can think really just organize how an LLM is used over time. So another way to think about this is that using an LLM prompt is like using an assistant to answer a question, while using an agent is like giving that assistant a goal to achieve, where asking and answering questions is just one possible step that might need to be taken in a much longer sequence involving decisions, tools, and iteration. And this brings us to the idea of a workflow, because once work becomes multi-step, it's often useful for it to be repeatable. And this is where agentic workflows come in. An agentic workflow is a structured sequence of steps that works well for a recurring task. It can be thought of as being a bit like a checklist or a procedure that you apply to an agent loop. The workflow defines what happens first, what happens next, what to check, and when to stop. As agents can trigger other agents, a workflow step could also be performed by another agent. Because, though, of the probabilistic nature of large language models, even though the workflow itself is repeatable, running the same task multiple times will usually produce different results. And we should talk about context, because with large language models, it's all about context. it's important to be clear about what context means for a large language model. Context is the information that is provided to the model at the moment it produces an output. So, this can include the current prompt, instructions, previous messages, and any additional text or data like a file attachment that you've supplied to the model. If something is not in the current context, the large language model is not able to take it into account when generating its answer. Importantly, context is not memory in the way that human beings have memory. The model does not remember past interactions unless that information is explicitly included into the current context. So, how can we expand context? How can we enhance it, improve it? Well, one way that we can do this is with something called MCP, or Model Context Protocol. And this is used because managing context becomes a challenge in multi-step systems, particularly when different steps involve interactions with different tools and different systems. So at a conceptual level, MCP, Model Context Protocol, is primarily about achieving consistency. It ensures that context and the capabilities that are presented to a model are provided in a predictable way in each step. So MCP gives LLMs context in a consistent package. As an analogy, we can think that MCP is kind of like an updatable briefing pack that we give to an agent before each step, and along with the goal and clear boundaries about what the agent is allowed to see and do. So MCP keeps that briefing pack consistent across steps and systems. MCP also makes capabilities available to a model explicit by defining what actions or data or information are available at each step. Examples of actions or capabilities would be things like adapting a configuration in another system or tool, updating the content within another system or tool, or triggering a step such as a tool-based validation or a simulation as part of the overall loop. And this brings us then to our next piece of terminology. How can we enrich answers? This is typically achieved with something called Retrieval-Augmented Generation, or RAG for short, and this is very commonly used alongside MCP. And what RAG does is it adds an additional step before an LLM generates text. Relevant information is retrieved from a known external source and inserted into the context of the LLM. The LLM then generates output using both its learned language patterns and the retrieved information. Often, the resulting output when we are using RAG will include references or links back to the retrieved source material. So we can think that RAG is a way to enrich that context and also our answers that we get when we're using an LLM. So, if we put it all together, these ideas connect naturally if we're working with an LLM. Agents and workflows describe how work is organized over time. MCP then describes how an LLM's context and capabilities are managed consistently across steps and systems. And RAG describes how additional information is retrieved and brought into context. Together, these explain how LLMs can be used in structured, repeatable ways to support multi-step work, the kind of work that we do daily as engineers. And this is a great question. Where does the human fit in? So we just talked about doing it as engineers. Where do humans fit in? Well, there's two main concepts for this. The first is where a human has direct control at certain points in the process, and work stops until an authorization is given by the human to continue. This is known as having human in the loop, or HITL for short. Our second concept is human on the loop. And this means that the system operates mostly autonomously, but a human is there to supervise the process and can intervene if or when needed. That's everything we're going to really talk about today. So as a summary, an agent is a goal-driven loop that's built around a large language model. Agentic workflows add a repeatable sequence of steps, and MCP stabilizes how context and capabilities are provided to a large language model. RAG then enriches that context with relevant information, and human interaction may be human in the loop or human on the loop, HITL or HOTL. If you want to know more about large language models and AI, then in a future episode, we're going to consider how we should use a large language model appropriately. Also, make sure to watch out for upcoming special editions of Engineering the Jigsaw that will explain how Vector is enabling its products with AI. Make sure to join me after music if you want to get in touch. Really hope you've enjoyed this episode of Engineering the Jigsaw. Make sure you give it a thumbs up in YouTube. If you have questions or ideas, then give us a comment down below the video. If you don't want to do it in public, if you want to keep it private, then drop us an email to our special email address, engineering.jigsaw@vector.com. You can find a link to our webpage with those contact details on in the description for this video. Make sure that you subscribe to get notified as we release new episodes and as Vector publishes its excellent and informative videos on its YouTube channel. Make sure to check out our playlists. We have our foundation episodes playlist and also intermediate level playlist as well, for you to binge and catch up with. We'll catch you for another episode soon. Goodbye.